Everyone, I'm Marina and I'll be there as a tech support during the tutorial. And I want to introduce you to our tutor, Milena Stojic. She is a teaching associate at Faculty of Mathematics, University of Belgrade, and she will hold the introducing to data mining, especially for healthcare domain, and enjoy.
Thank you for presenting. Actually, I am a former teaching associate. At October, I ended my work at the Faculty of Mathematics because I am in February. I'm going to PhD studies in Barcelona Supercomputing Center, just from area of machine learning in life sciences. So before we start, I want to know the structure of participants. How many of you are students? Can you raise the hand? Okay, I think I thought that you can. Okay, I will now share my screen. Just a second to find. Irena?
Can you do it now?
I can't share my screen.
Try it now.
Okay. Now it's fine. Okay, let's go to our presentation. Just to find. Okay, we will switch from presentation and Orange to. Okay, the overview outline of our presentation today. At first, we will give some introduction to our today tutorial and the goals of our tutorial. After that, we will give some information about showcase and about dataset and the goals in our showcase. And after this, we will show data mining concepts. And at this part, we will switching presentation and Orange data mining tool. So let's start. Okay, introduction. Objectives of our technical tutorial is just an overview of just basic data mining concepts. And the programming knowledge for today's tutorial is not necessary because we will work in graphical data mining tool. In the graphical data mining tool are implemented the most famous data mining algorithms, and you can use this without any knowledge of Python. Python is the most used programming language in data science. I chose Orange data mining tool because this is tool with the most comfortable graphical usage interface, and this tool is the easiest to learn and to start with this tool, and also the support and documentation for this tool is also very accessible, and you can find most source for this tool on the internet. Okay, besides Orange, there are available other graphical tools as Knime. Knime is more difficult to use, but this is also the very common tool in data science world. And also, this tool is also free as the Orange data mining tool. These tools are free. And the IBM SPSS modeler, this tool I used at my faculty below the license, but this tool is not free, and this tool is very powerful for financial predictions, and this tool is very used in financial applications. And because of this purpose, this tool is not free. Okay, now today we will show just the basic concepts of data mining, and idea of this tutorial is to encourage you to dive more into data mining world and to start learning in data mining. We today will show some example in which we will show all the basic steps in data mining process and some of common data mining algorithms. Okay, let us go to information about showcase. In our showcase, we will work on data about patients. About patients, the goal of our models will be prediction if patient have heart disease or no. This is disease is very hard and very dangerous disease. So it is usable if we find some hidden knowledge about heart disease to predict and how to to cure this heart disease. We will work on heart disease data set. This is data set above 302 patients. Each patient is described with 14 attributes about their state. One of these attributes is attribute which say to us is if the patient is has patient disease, has a patient heart disease or no. And this is data set is downloaded from UCI repository. I will show now this repo to you. I know we see it. Where to chat or can I send materials after technical tutorial? Is this okay?
Yes, of course, but just share to everyone, please.
Okay. I will show, but now I'm switching to
okay.
materials and the rest of materials. Okay, this is information. These are informations about our data set. Each patient, just to show all the attributes, each patient is described by age. Everyone who is from healthcare domain knows that age can influence to heart state of patient. If patient is older, this is the bigger risk of heart disease. Data about sex is patient is female or male. CP, this is data about just to see about chest pain type. The chest pain type can say to us about heart disease, and there are values which say about heart chest pain type, and there we have 4 heart type. If you are from healthcare domain, you know about all of these types of pain. Okay, other is resting blood pressure. When patient is in a rest state, there is a measured blood pressure, and blood pressure is, you know, also the important attribute for us. It also can say if patient has heart disease or no. Data about serum cholesterol, you know about this. VBS about blood sugar, about EKG. We can also view more information about this attribute. And 0 if this is normal. Is it some abnormality? Is EKG or other of two values? I'm not from healthcare domain, so I don't know about these other two types of EKG. But probably this is if is too big heart rate, or if there some arrhythmia. Okay. Maximum heart rate achieved. This is also danger if heart rate is too small or too big. Exercise-induced angina. If this is angina induced by some exercises. This also can say to us if is there heart disease. And also there are other of attributes about patients. And at the end is target attribute. Target attribute is diagnosis of heart disease, or is patient has heart disease. This value, as it is mentioned at the beginning, if this is value is 0, that patient hasn't any heart disease. But if patient has some kind of heart disease, this takes value 1, 2, 3, or 4. Okay. In this example, we will just classify patients if patient has any heart disease or no. We will not classify patient to a certain kind of disease, but only if has or no. This is a binary classification. Okay, this is about information. This is attribute which will this is a regular feature, and this is target attributes. Have you any question about data set? Can we repeat or in more in detail describe some of these attributes? Just to see in chat. Okay, no question. Okay. Now we can turn back to presentation. This is about the data set. About showcase. To return. Okay, this is all about showcase. The goal of our classification is to build a model by which we will predict if patient has heart disease or no. Okay, before we start, I will show to you how orange look like. This is some hello world window in orange. As you can see, Orange is a graphical tool, so the programming knowledge is not necessary. We will build the data flows, and in data flows, we will transform our data, application data mining methods, build models, evaluate models, visualize the data, and like this. You can see that is very comfortable and very nice graphical user interface. And to see when you can download Orange, I will rest the link in chat. Orange data mining, you can download, just to return to home page. Okay, this is the home page of Orange data mining tool. I will leave this link in chat. Okay, from this link you can download this tool. And if you click, when you click on this tool, you can download the Orange tool. Just to open. Okay, and you will there find your appropriate version. There is more ways to download this tool. Okay, and documentation is there. You can view the docs about all notes for everything, if you know. And there are some examples. But when you download the Orange tool, you can view examples in a home window. I will now close this window to show from beginning. Okay, just a second. Okay, now we will open Orange. Orange 3 is my version. Okay, you can, there is link to video tutorials. You can also discover more about this tool. There is some get started tutorials if you're new to this tool, and there are some common examples. Example also can help you to more understand this tool. And now I will start my work. I will start my flow. Before I start, I will come back to presentation. Just to okay, I'm not familiar with this kind of slides. I used to use LaTeX Beamer, but for these purposes, Google Slide is more comfortable. Okay. Why data mining? Thankfully, to development of memories, now we have a computer with very, very large memory. And thankfully to development of measurable measuring instruments, we can collect a huge amounts of data. For example, in hospital are collected huge amount of data about patients, or in meteorological stations, there are collected huge amount of data of meteorological data, and due to this we have a large amount of data, and this is very useful for us. On this very huge amount of data, we can gain some hidden knowledge which you you can't find but by traditional scientific methods. You can find some hidden knowledge and templates, and you can learn some hidden information from data. And this hidden information you can use in further development of science, development of new therapies, new medicines, and much more. So this is a goal of data mining. To go, what was this? Okay, basic steps in data mining are composed of, firstly, import of data sets. Data sets are the sources of data which we use in data mining. Data pre-processing is preparing our data. Visualization of data, in some cases, can help us to gain some view of data and to gain idea which method we should use. Application of data mining is heart of data mining. In this step, we build the models and applicate data mining methods. In this, we work evaluation is if our model was successful and how much is the score of our model. And at the end, we eventually, in some cases, can show visualization of data. Okay. Import of data sets. Before start of data set, we have to import all data sets. Data sets can be from various sources. Some of them are files. We will import data from one single CSV file, comma separated file, from databases, from web source. And when in data mining, when we use data from different sources, from different formats, this is challenge to build the common set of data which will be used in data mining. We won't work with this. We will stay just on one file, one source of data. And before every data mining process, we have to good understand our data and or features in data. In practice, when in companies work data scientists and in companies in practice work data scientists and people from domain, which better understand the data and the meaning of data. Now to show how we import data in Orange tool, we can see that we have more sorts of node. And at the beginning, when we import the data, these are data nodes. In these nodes, we import the data. And now we will choose a file node. In file node, we import data from file. We also can use, we have other source of data as this is for databases. And we also can gain statistics about feature. Now we will use the file, and we have to open the file. Now I will find in File Explorer our file. This is how this is. I will send after the tutorial to you this file, because this is file adapted for this tutorial, not the same from UCI. Okay, and now we imported the data, and there we can see all of features. And this is role in data mining. There are standard features. Based on this, we will build a model. And hard D, in preparation, I named this attribute in which is about diagnosis of heart disease, and this is target attribute. What means this target? Target means that this is attribute whose value we predict in algorithm. And now this is imported. Click to apply, and this is imported. And we also can check if this is imported properly. We can use for this data table, and we connect file and data table. All actions in data mining in our flow are represented by nodes, and there we firstly imported our data set from CSV file, and there we will show imported data in a table. It is useful when you want to check if data is imported properly or not. And there we see that is okay, imported. And there we can see values of attributes in data set. This viewer set target attribute at the beginning. And we can view this 0 if patient hasn't heart disease, and other values if patient has heart disease. Okay, we now view the data. So go with next step. Okay. Okay, pre-processing, as we mentioned before, pre-processing is a necessary step. In this step, we prepare our data for application of data mining methods. The data at the beginning is not in a suitable format for application of some certain algorithm methods, and algorithm methods would not be efficient for this source data. So we can firstly to prepare our data, and this depends of some data, if data were already prepared or not. And there are some steps which can be covered by pre-processing. We can transformation value of columns to modify values in column, or to remove columns, rows with missing values. In some data sets, you can have some missing values. These values can be if the value is unknown, or the value is lost, or the value is not known, and much more reasons. And for some algorithms, missing value can influence to efficiency of the algorithms. One of this binarization. This is step in which we from some set of values we transform to two set of just two potential values. Feature selection in some data sets are covered more attributes and some attributes which are not usable to us and which are not relevant for heart disease. For instance, if ID of patient is included in our data set, ID of patient is not relevant for determining if a patient has heart disease or no. So this attribute we have to remove. If we don't remove attribute which is not relevant for data set, our model would not be efficient. Our model would consider this attribute and this will influence to our results. And there are much more pre-processing methods. And now we will show how we do pre-processing in Orange and which pre-processing we will do. For simplicity, I prepared already the data. The initial version of data had 76 features, but I removed the most of these features and reduced just to 14. To 14, the most relevant features. And now, what can we do? We can transform this column to values just from set 0 and 1. We not consider if patient has one heart disease or some of other heart disease. We also interested in this if patient has heart disease or no. Not exactly kind of heart disease. So we will transform this column to values just 0 and 1. All values from 0 to 4, which are assigned to states when patient has any heart disease, we will transform just to 1 to do binary classification if patient has heart disease or no. Okay. Attributes, notes for transformation of data, therefore for pre-processing, are in transform section. And there we can see many different kinds for transformation of attributes. And now we will use attribute, we will use some other node, not from this section, but some node which is also for pre-processing from this section, edit domain. Oh. In edit domain, let us connect the data with this node to do action pre-processing. We now use which column we want to change domain. And we will choose heart D. This is target column. And we will change, we can there see targets, values of categories in this column. Anyway, you can see these colored types of attributes. Red stands for numerical type of numbers. Green type, labeled as C, stands for category type. In fact, type which has values from categories, not numbers. Okay, we will now change this. 2 we will transform to 1, 3 will transform to 1, and 4 we will transform to 1. Okay, and now we do apply. And we can check if our data is transformed. We will check there this. Okay, something work. Just a second, let's see what happened. Okay, I forgot to, this is action, and when we show the data, we have to connect with start, also with the import node. Okay, now we can see that data are transformed. We only have zeros and ones. And now when we transform our data is ready for classification. To return there. Okay. Before application of data mining methods, we can optionally give the visualization of data if we can do this. And in our example, we want to do this, but in practice, you can use visualization to show view of data. Some visualization you can show how are your data and which methods you can use. But I won't use this at the moment. You can also give visualization at the end after application of data mining methods to show results of application of model. But now we won't use. There is, for instance, visualization of data set of some other data set named Iris. This show distribution of data based of two features from Iris dataset, and you can see that one class of Iris is different from other two classes in this dataset. Anyway, Iris dataset is also very good dataset for the first step in data mining. So I will also send link for this dataset. Okay, and now we go to application of data mining methods. Before I start with this part, I want to know if you have some question or if of parts, previous parts was confusional to repeat some of this explanation. Anything if it isn't clear, you can ask me. So have you question? Cost. Have attendees some of question? No question? Okay. Okay, we now will start with the data mining methods. Data mining methods are heart of data mining process, and in data mining methods, idea is to train the model by data mining algorithms and to applicate model to data instances. Data mining methods are split into two common classes: supervised learning methods and unsupervised learning methods. In supervised learning methods, we won't cover unsupervised learning methods, but I will briefly mention also this class of methods. In supervised learning methods, this is idea, oops, not this. This is idea to use instances from dataset. In dataset, you have given data about instances and targets about values of targets attributes in dataset. And the idea is to, based on all this information, you build the model which will predict value of target attributes in future instances. For instance, in classification, in our case, we will build classification model based on our data about patients, and this classification model will predict if some new patient have heart disease or no. And this is because to this because to this supervised learning methods, name this supervised because you know values of target attributes, and you have to, based on known values of known target attributes, you have to train the model. Okay, only difference between classification and regression. Classification, you predict class category of some instance. When you have binary classification, you predict one of two potential classes. Our classes in our case, if patient has heart disease or no. These are two classes: 0 if not, if have not heart disease, or 1 if patient has heart disease. Regression is in regression we predict numerical value. Numerical value also can be a target value, and idea of regression is to predict a numerical value. For instance, you can build a model which can, according, for instance, on your height, this model can predict your weight according to your height. This is one simple example of regression. Okay. For classification, we will consider some of common methods for classification, but I will not go in detail and in mathematics in detail, because I want only to show basic ideas to you, and when you see basic ideas, you will be more motivated to discover more about deeper about algorithms. Okay. Other class of data mining methods are supervised learning methods. Idea of unsupervised learning methods is to find some templates in your data. One of common data mining methods, unsupervised method problems are clustering. Clustering finds potential groups in instances which are more similar instances. For instance, on YouTube executes clustering algorithms, and YouTube finds groups of more similar video clips, music video clips on YouTube, identifies groups of video clips, and groups often are appropriate to two kinds of music. Identify some all music groups from rock music are will be in a rock music group, or some pop music videos will be in other group of instances. But we will not. But if this was a confusion, today we will not consider unsupervised learning methods. But we can. But in practice, we also can apply unsupervised learning methods, for instance, to group patients, more similar patients, and at the end, it would be interesting to compare gain group with real classes of patients. We will not do this together, but this would be idea today. Okay, because now this, I only formed a presentation for the first part, and now we will apply data mining methods. Before application of data mining methods, I will show the basic idea of data mining methods. At the beginning, we will applicate three classification. All models, all data mining algorithms for classification you can find in model section. For all supervised methods, you can learn about many of these methods. Today we will consider three methods and a neural network. I suppose that you heard about neural network. But before we start with the tree classifier, I firstly want to explain idea behind tree classifier. What is the tree classifier? Okay. In tree classifier, I just to find decision tree example to show you some picture. Okay. This is good just to open in new tab. I hope that you see some is bad quality of picture, but I will show idea. In this method, we build tree. Tree will be our model. In tree, we come from root, and in root, we is asked a question about value of attribute. For instance, in this example, if age is lower than 30. If this is lower on 30, we start in left subtree. Is not, we start in right subtree. And then we go in next node. It's a lot of pizzas. If it's eaten a lot of pizzas, is this attribute is yes, we know in left subtree, or no in right subtree. This is just simple example of a decision tree, but idea is to, by training the model, we build this tree. And this tree will be classifier of patients if patient has heart disease or no. In this tree, for each patient, at the end, when we work evaluation, for each patient, we will go through this tree, and for each patient, we will determine is a patient is has heart disease or no. At the end, when we come to leaves, this is a subtree, and when we come to leaves, in leaves are classes, assigned classes. In this example, if age is 30 and eat a lot of pizza, if not, we come to class fit. And when we come to leaf, and class in leaf is the assigned class. And for more patient, we predict the class, assign the true class from data. It is the better classifier. I hope that you understand the idea of decision tree. If there is some question about decision tree. Okay. Now we will show in orange how we will build a decision tree. We choose a tree node. And in tree node, we connect with data table. And we can there tune the parameters, a minimum number of leaves. If we split subsets when we build a tree, I will not go there more in detail. But when we build a tree, we build a tree, but considering a subset. Goal when we build a tree, the goal is to more clearly subsets to split. I don't know how to explain this on English, but idea is to not be to be less different classes in each subtree splitted. This is idea when we build decision tree. And now we will tune this. And also before we start classification, we have to split data and on a train subset and test subset. What is the idea of this step? Idea of splitting data on a train subset and test subset. Idea is to be train model just on subset or of data. And when we train model on the part of on the part of set on this part, we now test our model on test part of subset to check if our model is good or not. And now for train test split, we use from transforms node, we use a data sampler. Okay, if we connect data set with data, transform data with this node, and to determine which percent or data will be train train set of data. Idea is to the most part of data is to be the most will be in train set. 70% will be in train set, the most of instances. Idea is to train on this percent, and on other 30%, we will test our model if this is okay or not. If we set more percent in train data, we can have overfitting. Overfitting is situation when your model is too much fit on your data, and this model is not good for unseen data, is not good for unknown, no seen data. And because to this it's important to leave enough percent for test data to validate real quality of our model. Okay. And now, after this, let us evaluate quality of model. We can do this by test and score node. We have to connect model node. In this node, our model is trained according to data set. And now we have to check quality of this model to see why this not connecting. Okay, and now we can see results. I will explain all of these numbers. I now will explain precision. What precision stands for? Precision stands for, I will write there to be more clear, to true predicted, just a moment, to true classes predicted with this is measured. True is when model predicted real class of instance. When assigned in a class from decision tree is same as a real class from data set, and this is number of instances for which is predicted real class of instance, and all this is number of all patients. In our case, this is 302, and we can see in our example that precision is 0.94. That is 94% of instances is predicted. Sure. So this is good precision on train data. But now we have to check is this measure is also good on test data. On test data, it happened, but this doesn't happen in practice. In this example, precision on test data was better than on trained data. So our model showed good results on unknown data, and because our model showed good results on unknown data, we can our model consider as a good model. If this was the case when the results on trained data is much better than result on test data, this would mean that our model is not good, and that is not our model is actually overfitted to train part of data. I hope that you understand this part. I will add these measures on presentation to you can see after this presentation if something stay unclear. Okay. Do you have questions? Some questions? Irena? If there are some questions from attendees.
I don't see any questions.
Okay. I want to explain some concepts if are some part of tutorial. If I some part explained confused, to repeat again to be more clear. Okay, I now will show a concept of confusion matrix, and after this I will apply another one data mining algorithm. And after this, I will leave space for more questions. And after questions, we will finish. Okay. Actually, this step test and score, this step was a step of evaluation of model. In evaluation, we consider the quality of our model, if our model is good or not. In our case, decision tree showed good quality of model. Some improvement of decision tree is to make a model which is composed of more trees. In this case, we consider model based on just one tree, but we can also use algorithms in which we have more trees in our classification, and we build more trees, and we consider gained class as results from more trees. Which class is in the most trees, this class will be assigned, and logically this classifier often shows better results than a single tree model. Okay. Let us show confusion matrix evaluation. Confusion matrix is typically for binary classification. And I will now connect this. I will firstly show confusion matrix, and after confusion matrix, after I show confusion matrix, I will explain meaning of results. Okay. It's better to show. Okay. In a confusion matrix, we see we can see number of predicted classes, and number is actual classes. These are classes predicted for some instance. There are instances for which is predicted 0 class, that is patient has not a heart disease, and there is predicted class 1 when patient has not heart disease, where patient has heart disease. This is class 1. And in this case, classifier predicted for these patients, for 167 patients, classifier predicted class 0. Patient doesn't have heart disease. And for 136, classifier predicted if that patient has heart disease. And this is actual class. In row 0 is number of patient whose actual class is 0. That is, these patients actually in real has not heart disease, and this is the number of this patient. In the first cell in this row, this cell is for patient who hasn't heart disease, really hasn't heart disease, and for them is really predicted that they hasn't heart disease. And we can see that is for most of them is predicted correctly. And other cell in this row, cell in column for this patient is predicted that they are has heart disease, but actually this patient has not heart disease. And for this patient, model was wrong. These patients are not predicted correctly. And we can see that is a very small percent of these patients. The most of patients for this from this class is correctly predicted. Similarly, in this row are a patient who really has some of heart diseases, and in this column for nine patients, classifier model said that these patients has not heart disease, and for this 9 model was wrong. But in this column there are patients who really has heart disease, and for this patients model was correctly classified. Model said that these patients has heart disease, and we also can see that for really patients with really heart disease, model in most cases was correct. So based on this matrix confusion, we can also see quality of our classifier. And this matrix confusion, based on this matrix confusion, we can see if model some classes classify more correctly, or for some classes often is wrong. So this measure gives to us more information than just precision. If some class is usually not predicted well, this can say to us that our model have to be better, that our model is not good for these classes. When we have, if we class that is appropriate to false, 0, if 0 is false, patient has not heart disease, and this other case when patient actually has heart disease, if this class is true and this class is false, this number we call true negative. This class is this number is a number of true negative instances. We have really 158 is a number of true negative patients. that is patients that are negative to heart disease. This is true positive rate of our classification when classifier correctly guessed positive result, and this is false negative when false positive to correct false positive result when model said that that patient is positive to heart disease, but actually is not. And this is a false negative rate when classifier set this that is patient has not heart disease, that is patient is negative, but actually patient is positive. And this is one of the most important and most common measures of quality in classification. Okay, I now will show another one method of classification, but I'm not have not much time to go deeper into explanation of this method. I will explain a method, a neural network. Just to correct this, because before I give a neural network, I forgot to visualize model from our classification. Model in our classification is tree, and we can show and view a picture of this tree. How is our tree? And I will connect model node with not this to connect model node with tree viewer, and let us zoom out. We can see a model classifier. Just to zoom out. Okay, at the beginning, value of this attribute is considered, and if this attribute is less than 3, we go in this subtree, and we further examine this value of attribute. And if this attribute is greater than 3, we go to this node, and we continue to further examine the value of attributes. And we can see, just to show more on picture, we can see that in this attribute, we can see that in left tree, we have more negative patients. And in right subtree, we have more positive patients with really heart diseases. And when we go to age node after this node, situation is clear. If age is lower than 57, in this node, patient hasn't heart disease. There are more instances with positive class. And the ideal situation is when we, after this attribute, on some side we have more clearly situation, not no more instance from one class. I hope that I explained this appropriately. Okay. And after this, I will show to you a neural network. A neural network, I can't explain in detail, but the neural network is based of concept of perceptron, of neuron, and this this network is built from layers, in layers and output layers, and all nodes inside are perceptron. But I haven't time to explain this more, and I will there just show application of this algorithm. Okay, we will connect with this node, and our data is trained. We can tune the data. I wanted to explain to you, but there is not time for this. I will see to leave some explanation about this algorithm on slide. But let us connect this with evaluate node. And there we can see results for all algorithms. In our case, a neural network gave low precision decision tree classifier. When you in practice, when you work some classification, you will try more algorithm and consider which gives better results. Let us see confusion matrix. In confusion matrix, let us see confusion matrix for neural network. In this we see that is more wrong classes, wrong predicted instances, but we also have good result. 87% of predicted instances is also a good result. Okay, now I have not more time. I hope that it was clearly to you. I will left presentation and stream for Orange in materials, which organizers will send to you. Sorry to my English, I'm still practicing English, and some things which I would explain on my native language, I would better explain on native language, but I hope that you understand the point. I encourage you to practice more in Orange. You can install Orange and discover all options and nodes in Orange. And also you can view documentations for these options for which you are interested. And also you can, in this repository of datasets, in UCI datasets, you can find the datasets, good datasets for practicing. I mentioned at the beginning IRIS dataset. This is the best dataset for the beginning in data mining, but I want to motivate people from healthcare domain to use data mining, so I used heart disease dataset. Besides UCI data repository, you can also consider Kaggle. On Kaggle, I will leave both of these links. There are some good beginner friendly datasets from different domains. Okay. This was all from me. Just to return to presentation. Okay. Thank you for the attention. I will left my email in chat too, but it also would be on my presentation, and you can contact me on this mail. Now, at the end, I want to ask if you have some question. And if I have to some repeat again. Irena?
There is no questions yet. I don't know if
Okay,
will be.
let us wait for 1 minute more.
Okay.
I will anyway left all the materials that the attendees can view this material again. I know that my English is not too mastery, but I want to, and because to this I want to left materials for attendees to see if something is unclear.
We can wait for another minute.
Okay.
Does somebody have a question?
Visitors also can ask me in other questions. Also, some topics out of some data mining of domain topics out of presentation.
I suppose that's it.
They can.
Sorry, I can't hear you.
If there is no questions, I think we can.
Okay,
this.
okay. Thank you for the attention. I will leave to you or to some of organizers of all of these materials, including presentation, dataset, and all necessary links and streams from Orange. And visitors can view them and contact me to mail if they want to, if there is some more questions of this.
Okay, thank you, Milena. And
thank you, and to you.
Thank you everyone for watching this.
See you on conference.
See you.